Now I'm going to talk through a linked list and how that is implemented into the Jack link. So, get into it. In a list, we're going to have the atom null, so just an empty list, or an atom followed by a list. That's going to be just our definition of a list. It's a pretty powerful example, especially in computer science. We can now start storing lots and lots of things. In Python, one of the basic units is a list. Python really just has objects and lists are just kind of sequences of things. It looks much like an array, but it's a slightly different idea. So here are some examples of some lists. So null is a list. 5 followed by, 5's our atom, followed by the list of null. That works. Here we have a list which is 3, that's our atom, followed by another list. And inside that list is 5, comma null. So you kind of see we keep building more and more. And it kind of looks like this recursive list of lists of lists of lists. We abbreviate that because it gets very infuriating, and we kind of abbreviate that with parentheses. So in the null list is just 2 parentheses with nothing in it. This second list, 5 followed by null, is just 5. And you can kind of see that we keep going. We're not going to show that this recursive listing, for instance, the last one is 2 followed by 3 followed by 5. Just that's what's in the list. We don't show kind of that recursive sets of lists. So when we think about lists, if we have V's, that might be pointing then to the head of the list. So this last line, we look at, we're storing number 2, V's pointing to that 2, and then that's the data. And then next, kind of unit of the list, that's then going to be linked to some other list in memory. And then, of course, in that list, we're going to have 3, and then that's going to link to another list, and then that's going to have 5. That's going to end up being linked to just null, the null list. Well, this is called a linked list because each then element of the list is linked to the next item. So you can jump in anywhere into the list and then kind of follow that down until you reach the end. So let's make a list API. If we have a class called list, well, we're going to have a constructor that's going to make a new list. We need to pass that the CAR and CDR. And these ideas come from some old assembly language mnemonics when they first created the Lisp, LASP language. And that's really going to be the head of the list, I think the address register, and the rest of the list, the destination register. But don't worry about that. All right, we need a method to print the list, and we're going to need a method to kind of dispose of the list and get rid of it. So that's the list. Let's look at kind of some code that we might interact with the list. We want to create a list, manipulate it, and then start printing it. So we're going to create a new list V. We're going to say let V be a new list. We're going to give it the values 5 and null. So that's our idea. We give it an atom, 5, and then kind of what we want to link it to, then the next list. Works. Then we're going to prepend to that list, I guess. We're going to put something in front of it. We're going to say let V be a new list. We want to have 3 followed by the current list V. So that again creates that list, returns a new list. All right, now we're going to say let V be a new list. And finally we get to the point where we say 2 followed by V. So we keep kind of taking our list and building onto it, and it's always now pointing to the next one. So finally V, in terms of the main function, is just pointing to the start of our list. Then when we print that, we can go through and print 2, 3, and 5, the items in our list. We dispose it. Yeah. So that's kind of the abstract we want to do. Now we can go look at the step. So when we created code, we use these following functions. So in our list, we're going to need a couple of fields. We're going to need the data, what's currently in the head of the list, and next, where the next or the rest of the list. Think about like the data and then next. Then we construct a list. We're passing the CAR and the CDR. We are going to let this particular instance of list data be CAR, this new value we're passing, and the rest of the list be put in the next field. And we simply then return our reference to ourself. So we say let list be V. That just creates V, some variable not really doing anything. We run let V be a new list referencing 5 and then null. This sets this up in memory. We assign the values of data, and we assign just the null item to the rest of it. All right, now we say let V be a new list with 3 and then a reference to V. So look where V is pointing now. It's pointing to the start of this list that stores 5. We sever that tie. We create a new list, and then now V is referencing now the head of this new list 3. And of course, this list refers to the old V, so they're still linked by the list we have. Likewise, do the same thing. We create a new list. So in the end, V points to the head, and then our next items of each list is linked to each other, so we can follow that down back to null. And this is now be equivalent to the following lines of code if you want to simplify things. So accessing this is actually really neat. So if we want to print a list, what we really want to do is print the first item and then get the next item on the list and kind of go through and just follow that tail down. So that's what this code's going to do. So our client code's going to say, create a list and then print it. So what's going to happen as we go through the code, when we call print, we want to print 2, then 3, then 5. So we're in the print for V. That becomes just this. When we call a function and it's working on itself, that gets assigned just the register this. We're going to create a new list called current. We're going to say let current be initialized to this, the first item of our list. So this when we start talking about this, we're referring to ourself. In Python, that's usually when you just say self dot whatever. In the Jack language, it's going to be this. All right, so this and now current are all pointing to the start of this list. And we're going to say, while this current list we have, this new variable called current, is not null, then we're going to start executing some code. So we're going to print the integer get data, which in this case is 2. We're going to print a space, and we're going to say current equals current dot get next. What happens then? Current will go to that list get next, which points to this list 3, jump over there, and we're going to say, all right, is current null? Well, no. So we're going to then print the get data, which is 3. We're going to print a space. We're going to assign now current to the next item. Say, all right, print this, 5. Print the space. Going to assign current to the next item. We say, all right, is current null? In this case, yes, current is null. We are done. We break out of our while loop. We return. We've now printed that whole list, just kind of traversing down all of. And when we're back out into main, the V reference has not changed. All right, one more item is going to be now disposing of a list. So when we print a list, we start at the head and kind of work our way down to the tail. If we just want to dispose of a whole list, if we dispose our head first, well, now we've lost the references. So now we just have this memory that we can't use. So instead what we want to do is go down the list, get to the end where it's null, then start working back up, disposing it kind of as we go. It's kind of like if we're climbing a ladder, we don't want to start breaking the ladder down from the rungs as we climb up. We want to climb up and break the rungs below us. I don't know why that analogy makes any sense. You'd never want to do that, but that's what we want to do. So after we're done with our list, we want to dispose it and free up the memory so the OS is happy. All right, we have our list V, we're going to call dispose. And here's what we do. We call dispose, and we're jumping into the method of dispose for V. So again, this is assigned to V. So if we say in the dispose method, this dot whatever, referring to itself. So while next is not null, so in this case, we check for this, is next null? It's not. We call it next dot dispose. Then we would then jump to the next list, and it goes into this, and it says, is my field null? No. Jump to the next one. Is my field null? So then we finally end up where at this point where we are next. Sorry, in this case it was next is null. Either way, we got to the end where we said we're at the end of our list. Next item is null. We break out of this loop. So now, right now, remember we're in this list 5, null. We deallocate ourselves and we recycle that memory. It's the OS kind of handles that, releasing it for us, and now we return. Well, now we're in this list, the 3 lists execution of dispose. So now we recycle that memory, go back to the top one, recycle that memory, hit the final return, and we go back, and V is now not pointing to anything. It's just a variable that has nothing assigned to it. So I think this is a really cool example. Lists are a very abstract, very useful tool in computer science. And we have now seen examples of building a list, this is a linked list, processing a list sequentially. That's when we printed it. Processing a list recursively, meaning going in and then recursing back up. That's when we dispose it. And just how you dispose of a list. So some of this disposal and kind of getting things ready are made by not only the compilation, but also some of these system level services to allocate or deallocate memory. And this is all achieved by doing pointer manipulation. So you've gotten a good feel for pointers already if you've done project 7 and 8. And now we're just really continuing the idea about pointer manipulation to do that. The pointer manipulation is done by the code, because if you look closely, we did not really touch any pointers ourselves. We just are calling different classes and objects. All that manipulation is done by the compiler, which we'll get to subsequent projects. So anyway, I'm going to stop there. That's my intro to Jack, some of these different ideas that we have with, we've done procedural programming with Jack. We've seen how Jack is object-oriented. Now we've seen some examples of pointer manipulation for lists. So there we go. I'll come back with some just syntax and that sort of stuff.